Hello, in this video I will talk about favorable characteristics of depleted uranium that made them attractive for the military use. Enriched uranium was first manufactured in the early 1940s when the United States and Great Britain began their nuclear weapons programs. Later in the decade, France and the Soviet Union began their nuclear weapons and nuclear power programs. Depleted uranium was originally stored as an unusable waste product in the form of uranium hexafluoride, in the hope that improved enrichment processes could extract even additional quantities of the fissionable U-235 isotope. The re-enrichment recovery of the residual uranium-235 is now in practice in some parts of the world. For example, in 1996, over 6,000 metric tons were upgraded in a Russian plant. In the 1960s, depleted uranium was investigated for use in counterweights and radiation shielding because of its high density. In the 70s, the Pentagon reported that Soviet military had developed armor plating for tanks that NATO ammunition could not penetrate. The Pentagon began searching for material to make denser armor-piercing projectiles. After testing various metals, researchers settled on depleted uranium. At that time, the US military started developing depleted uranium munitions. Development of depleted uranium munitions included its use for armor-piercing rounds, which benefit from DU's ability to penetrate heavy armor effectively. The first significant stockpiles of depleted uranium ammunition were created during this time. In the following years, depleted uranium munitions were increasingly incorporated into NATO arsenals. The US military developed and deployed various types of DU ammunition, such as here shown the M829 tank round. In parallel to military use, depleted uranium was used in civilian industry for counterweights in aircraft and radiation shielding in medical and industrial settings. During the Gulf War in 1990 and 1991, depleted uranium munitions were used for the first time at the battlefield by US and coalition forces, and after that, depleted uranium continued to be extensively used. The effectiveness of these weapons against Iraqi armored vehicles demonstrated the battlefield utility. However, the war also raised concerns about the potential health and environmental impacts of depleted uranium. Later on, the use of depleted uranium in warfare became a subject of controversy. Veterans of the Gulf War and following conflicts reported health issues that some attributed to exposure to depleted uranium. Numerous studies were conducted to investigate the potential risks. Additional conflicts, such as the Iraq War and the war in Afghanistan, saw the continued use of depleted uranium munition. Public and scientific debates about the safety and environmental impact of depleted uranium persisted. Various international organizations called for bans or restrictions on the use of depleted uranium weapons. Depleted uranium is primarily used in armor-piercing projectiles known as kinetic energy penetrators. These projectiles are designed to penetrate armored vehicles effectively. Their high density allows for smaller diameter compared to equivalent lead projectiles, resulting in more efficient penetration. When depleted uranium projectiles strike a target, they show pyrophoric nature, creating incendiary effect and breaking up into smaller fragments, which can form a toxic aerosol known as depleted uranium dust. Depleted uranium is also used for armor protection, mainly to produce tanks with improved resistance to ammunition penetration. It is used in nuclear weapons to enhance the efficacy of explosion, and also in civilian industry to stabilize vehicles and equipment. The important question here is why depleted uranium became so attractive. So first of all, depleted uranium is very dense, so consequently, as said before, a DU projectile of a given mass has a smaller diameter than an equivalent lead projectile. Depleted uranium projectiles are pyrophoric upon impact to the target, meaning that the metal then burns, and they're also self-sharpening, so when it hits the target, it continues to sharpen. Depleted uranium munition can be fired from various platforms, including tanks and aircraft, with long-range engagement, so that allows it to strike the targets from a distance. Here is also suggested YouTube link with more information on the favorable military characteristics of depleted uranium. There are several war conflicts and battles known to be using depleted uranium. So first one is the use of depleted uranium penetrator rounds in the 1991 in Gulf War. It is estimated that around 300 to 350 tons of depleted uranium were used. Following, depleted uranium was used in Bosnia, in Kosovo, Iraq, Afghanistan, Lebanon, Libya, Syria, and more recently in Ukraine. The exact numbers for the amount of depleted uranium used in each of specified locations are hardly available. The use of depleted uranium in Yemen in 2015 has not been confirmed yet. Before depleted uranium was used in battle, there were also accidents involving uranium hexafluoride. In United States, there was an accident in which 32 workers were exposed to the cloud of uranium hexafluoride. At that time, one person died, while few workers with high exposure experienced short-term kidney damage. It was manifested as an increased level of proteins in the urine. This accident happened in 1986 in Oklahoma. Later, only 2 years later, in 1988, an attack jet of the United States Air Forces crashed onto a residential area in West Germany. The aircraft crashed into the upper floor of the apartment complex. Pilot and 5 people were killed. 50 others were injured, and many of them had serious injuries. According to the health issues occurring afterwards, there have been suspicions that the depleted uranium was used in the aircraft. This was though never confirmed. However, topsoil from the accident scene was removed with radiation warnings. A lot of residents and rescue workers reported skin diseases. Medical diagnosis concluded that these symptoms were related to toxic irritative dermatitis. In the following slides, comparison of different types of ammunition, including depleted uranium, tungsten, conventional high explosive ammunition, and kinetic energy penetrators will be given. You will be able to compare composition and use of those different ammunition types, as well as advantages and disadvantages related to military use, health, and environmental effects. Since the focus of this course is depleted uranium, let's start with depleted uranium ammunition. In the previous slides, characteristics for the use of depleted uranium in military were explained. So it's already said that depleted uranium is a byproduct of the enrichment of the uranium. It is less radioactive than uranium. And it's used as an armor-piercing munition due to its high density and ability to penetrate armored targets effectively. However, due to those characteristics, advantages are density and pyrophoric nature, better penetration, and self-sharpening. But what has been reported over the years are long-term health effects and environmental pollution. In regards to tungsten ammunition, it is an alternative to depleted uranium ammunition, and it's still used for armor piercing. It is effective, but considered slightly less effective than depleted uranium ammunition. However, no radiological health risks are reported. Disadvantages of tungsten ammunition are still environmental concerns, and it is more expensive to produce than depleted uranium. If we talk about conventional high explosive ammunition, it contains chemical explosives and destroys targets through explosive force rather than penetration. It has wide application and hits various targets. It has blast effects and sharpening. Disadvantages for this type of ammunition are high risk of collateral damage and it is weakly effective compared to depleted uranium and tungsten ammunition. Kinetic energy penetrators without depleted uranium. There are various ammunition with high density, such as advanced ceramics or composites. Penetration through armor is achieved through the use of kinetic energy. Advantages are no radiological risks, and it is definitely more environmental friendly in comparison to depleted uranium. Disadvantages in the military point of view is that it is less effective than depleted uranium ammunition, and it has potentially higher costs for the production. Thank you for your attention.